Our next presenter is the co-founder and CEO of Deepgram. Please join us in welcoming Scott Stevenson to the stage.
Hello, everyone. Also, thank you to Jordan for an awesome keynote and getting everybody kicked off and warmed up. And actually, I don't have to get everybody hyped about just the voice market anymore. So thanks, Jordan. But I'm Scott. I'm from Deepgram. Folks might know us for the models and infrastructure that we build that power voice AI. A lot of products that are built today utilize Deepgram under the hood in order to provide speech-to-text, text-to-speech, and voice agent functions. And our marketing team had a little bit of fun with our slides here, so I'm here to talk about going to the audio Turing test and beyond, and hopefully, hey, we want to fly here, but hopefully it's at least falling with style, if anybody gets that Toy Story reference from back in the day. But I wanted to talk about where we started. So I'm a particle physicist. I built deep underground dark matter detectors, and I was 2 miles underground. And it's insane. It's like a James Bond lair, not kidding. There's guys grinding and sparks flying everywhere and cranes and all of that stuff. And actually, I think I have an image. This is what it looked like, and we were building these deep underground dark matter detectors. And I'll spare you all the details on it. If you want to talk to me about it later, go ahead. But suffice to say that the deep learning models that we were building in order to understand the data that was produced in these detectors was very, very similar to voice data. All of the outputs from these detectors were waveforms. It was about equivalent to 50,000 or 100,000 simultaneous voice communications, from a data flow perspective. And we built all of this 2 miles underground in this crazy location. We had to set up our own networks and cooling and all sorts of stuff. So it was a really cool time. But what we learned from that is how to take real world messy gross data, scale it up, build these amazing machine learning systems to understand what was going on. This is about 10 years ago when we were working on this. And the problem that we ended up having though was, hey, we knew all these things about how to process waveform data. But actually, that's not what got us into audio. What got us into audio was we thought, man, this is so cool what we get to do. We're working in this weird place, 5 people underground, et cetera. We're where's the documentary crew? That should be documenting what's happening here. And there wasn't one, and we weren't going to be one either. We weren't going to walk around with a camera, et cetera. You see cameras walking around today. It would have been great. But instead, we built little devices that were just like a Raspberry Pi with a microphone, a battery, et cetera. And we just made backup copies of our lives. We just thought it was too cool to forget, basically. And so we ended up with over 1,000 hours of data from that in this just weird scenario. And we knew that deep learning works in this waveform scenario. And so we just assumed that there are other people out there in the world. We're just some physicists in the hole in the ground. We're hey, all the speech people are probably working on end-to-end deep learning to understand what's inside audio. So we went out and contacted Google, Microsoft, and actually had independent meetings with them and said, hey, we'll give you this weird 1,000-hour data set of scientists talking underground. We thought they would be interested. I now know they would not have been. But that was in exchange, can you give us access to the end-to-end deep learning systems that you're surely building? And the response that I got was that's cute, kid, End-to-end deep learning will never work for conversations. Language is too complicated, And we're just I think these people have no idea what's about to happen. And so that's what gave us the confidence, to start Deepgram and just say all right, we are going to go start a company. We're going to build that. We're going to go live the monk life, of just rebuilding the entire voice stack from an end-to-end deep learning perspective. And then we started with search and to search through that audio. And I'll tell you just briefly, search was not it was a cool thing to build, and we were kind of trying to go to the last stage and just say, why do you need speech to text? Why do you need text to speech? Don't you just need embeddings? So it's essentially what everybody got familiar with over the last few years, where there was embeddings and fuzzy search, where like pinecone and that type of thing. So we did that for audio 10 years ago. And we went out to people and said, hey, what do you think? And they're like, that's neat, that's cool, that's awesome. And as a founder, that's not what you want to hear. You want to hear, where do I write the check? You want to hear like, can I get that today? Can I buy it? And that was not what we saw. And everybody was asking for speech to text. And so what we did was focus on that. We built this this search from an embedding perspective initially, but then we said, no, you gotta focus on speech to text if you want to get to passing the audio Turing test. And I'll define that in a second, but. So where did we start? We started with that. We started with speech to text, and let's see, yep. And it's not just speech to text. Like we started with, you got to get the accuracy right. It's I think most people in this room understand. Like if you don't have an accurate speech to text, it doesn't matter if it's fast. It doesn't matter if it's cheap. It doesn't matter whatever. It has to be accurate, right? So you got to start with accuracy first. And so this is what we focused on. And there's actually a lot of pioneers in this area. And again, we're kind of talking 10 years ago. Baidu was actually the first to put together a close to end-to-end deep learning model. It wasn't quite. Actually, they tacked on like an n-gram language model at the end. So it wasn't truly end-to-end. Google got close with a few things, but again, not an end-to-end deep learning platform. And then that's what we focused on at Deepgram, is building that. So during those first few years of Deepgram, we didn't really release a product. We built all this technology from the ground up, and patented some of it, et cetera. We're kind of secretive about what we do. I think it's kind of important in the voice space, but in all of these patents that we have are, if you look at the data on them, you're like, well, that's like kind of recent. Well, it took like years to get them verified and everything. That's the situation. But so like we were the first to bring transformers to ASR and scale them. We were the first to just do end-to-end deep learning for kind of all of voice, like classification, et cetera, that type of thing. But our first major product was speech to text. And one thing that we focused on is you got to get the price down, because if you think about all of the different systems that you need for making a voice agent and passing this audio Turing test, which I would define as being able to have a conversation for 5 minutes with a voice agent and like really not be able to tell that it's not a human. I think the 5 minutes is important because you can be tricked for like 1 turn or 5 turns or something like that. But you really need to kind of dig in. And but if you want to, like, passing that test is one thing, but doing it at scale and kind of making it actually valuable to businesses is a totally different thing. It has to hit a certain price point, and it has to hit a certain reliability point, and trust, and be able to run on-prem, and all sorts of things. And so this is what we focused on when we were releasing the product, and set the price. Like it's actually kind of funny. Investors ask me, like, what about price pressure from the hyperscalers? I'm like, whoa, whoa, whoa. We're the ones who set the price at that level, because that's what is needed in order to enable voice agents at massive scale. So drop the price 10x, increase the usage 1,000x, basically. So we focused on that, but initially it wasn't. Well, actually, I want to comment on over time the data sets that we've used. So initially, those models were only trained on like 1,000 hours, or maybe 10,000 hours. Now they're trained on tens of millions of hours, and the accuracy has dropped drastically from probably around 30% word error rate in those days to now like 5% for general data, and as low as like 1% for adapted models and custom models. But so, and this is what if you're not familiar with Deepgram's Nova 3 models, the accuracy is really good. But yeah, so is that it? Is that just accuracy? That's all you need? No, right? You need low latency too. And so let's talk about the picture of the world here, which is back in those days, 2018, 2019, et cetera. If you could cobble together a system, you'd be lucky for each part of that system to have like 1.5 second latency. Your speech to text, some kind of chatbot LLM text-to-text thing that you're putting together, and then finally, your text-to-speech generation. And so it might take 5 seconds, 10 seconds to do a turn or something like that. And we're like, this cannot stand. In order for voice agents to become real, in order to pass that audio Turing test, you have to knock down the latency. And this is something we focus on at Deepgram deeply. And for speech to text, yes, we worked on it. For the other products that we have, this is something that we focus on. If it can't scale, why bother releasing it? So we hit that, and this is great. But we just had some talks and chats yesterday with a bunch of people. I think a lot of people would kind of declare latency is like solved now from not all of it, but like it's in a pretty good spot. That's cool, and a lot of people worked on that. But now, what's next? Okay, if you want to make a voice agent, you have to have a high-quality voice, right? So I labeled this as like 2022 to now because there's a whole bunch of progress during that time. But it actually goes all the way back to 2016. And this is when Google released WaveNet. So if folks aren't familiar with this history, oh, actually, by the way, like some alternative like titles for this talk is like Old Man Yells at the Clouds, or like a brief history of audio AI, or like you whippersnappers don't really know, or whatever. Anyway, but Google had WaveNet all the way back in 2016. And it was an obvious good demonstration of what TTS could be. And I think I have a file here that I can play for you to listen to.
The pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
So it was talking about an avocado. But that was 2016. And so people think like robotic, okay, I know it's a little robotic and whatnot, but like at the time it was like, holy shit, this is like it's clear that TTS is kind of going to be easier than perception. It's clear, all of that, right? And then other companies in like 2022 to now like really jumped on that and made voice quality really good. This was also generated by WaveNet in 2016. So like, it was just clear from scientists' perspective, like, okay, the generative part is actually kind of solved. The voice generative part is actually kind of solved. We'll work on that when the other missing piece is solved. So I would just declare at this point in time, like, okay, the voice quality is like solved. And this is when Deepgram built Aura 2, which is our text-to-speech engine that you can try now in Vapi. You can try in a lot of different platforms or directly from Deepgram. But it's low latency, it can be run on-prem, has lots of voices, et cetera, and we're scaling up the language support and everything. So our research team focused on that, built a new architecture from scratch that's super reliable but also expressive. And we did that like in the last couple of years. Here's some stats for like a conversational like kind of B2B use case. Blinded studies show that like Aura 2 is doing really well from a naturalness perspective. Does that solve everything? You have speech to text, you have a great voice. We all know, no, it doesn't, right? There's another big missing piece here, which we could call LLMs, we could call text to text, we could call thinking, we could call reasoning, we could call RAG system, we can call whatever. I'm just calling it thinking, But that needed to be solved too. And they all kind of, like the big voice quality boom happened at the same time as the thinking boom, basically because the thinking boom like drove the voice quality boom. Because now you have this middle piece that is solving this problem built by OpenAI, Anthropic, all these folks. But you have this middle thinking piece that solves this problem. That was like the last piece to the puzzle. We all know it's not actually the last piece, but it's like the last piece to a minimal puzzle, that gets you going with voice agents. And that's when things like really started to kick off, right? And you got a few folks like building then early. This is like when Vapi really started to take off as a company, and lots of different companies in the last few years. And I would say it's like a clear dawn of a new era, and Jordan was hyping that up. I think it's not actually hype. It's like this is something that's turning on. It's never turning off again. It's like electricity. It's like cars. It's like whatever. It's a whole new thing that is totally real, totally going to scale, and like going to be $1 trillion market or more. We're all just going to have to figure out how to deploy it as fast as we can to increase the productivity of the world. But
Scott, your pedicure appointment is scheduled for Saturday at 2 p.m.
My voice agent's trying to talk to me right now. But yeah, these are the types of experiences that everybody knows are like super easy to do now. But yeah, are we done? The theme of the talk. Are we done yet? No, we're not, right? Because if you get a good voice, you get a good speech to text, you get you put the thinking in place, et cetera. Are there still problems? Anybody want to yell out any problems like interruptions? Latency, there's a trade-off between interruptions and latency, and so I'm here to announce a new model, some new products from Deepgram, which is voice activity detection. Okay, End of turn, okay, and streaming speech to text. Didn't you already have that? Yeah, well, actually, this is a model that's built from the ground up for streaming speech to text, which is something we've been working on for about 2.5 years. But again, like at Deepgram, we kind of, the way we think about it is like we're going to do it once, we're going to do it right. It's going to be fully streaming bidirectional. It's going to run on-prem. It's going to have all the qualities that you want, and it's going to beat our other models in accuracy as well. And so we're talking about that today. But I'll do an old Steve Jobs cliche, which is it's a voice activity detection. It's an end of turn. It's streaming speech to text. It's voice activity detection. End of turn. It's streaming speech to text. Actually, no, it's not. It's one product. It's Deepgram Flux. And so you can, thanks. And so, yes, you can use this in place of your speech to text if you want, but there's actually more, to the model. And so I'll talk about what some early users, the feedback that they have on Flux. I'll also talk some numbers. And so let's see if we can get this video playing too.
Ever feel like talking to AI is harder than talking to a human? It's either constantly interrupting you. Hi, my 6-digit medical ID number is 341.
Please share the remaining 3 digits of your medical ID number.
Or it takes forever to reply. My 6-digit medical ID number is 341246.
I'm glad you reached out. I can't access or store personal medical ID numbers.
That's why Deepgram built Flux. Flux goes beyond ASR. It's the world's first conversational speech recognition model. My 6-digit medical ID number is 341246.
Sure. I'm here to help with any questions about medications or anything else you might need.
Yeah, is my prescription for doxycycline ready for pickup?
Yes. Your prescription for doxycycline is ready for pickup.
Natural sounding conversations, no unwanted interruptions. If you're building a voice agent, make sure it's powered by Flux.
All right, thank you, Jose. He's here today. He has he's got a robot dog. Oh, there he is. He has a hat on, but he's got a robot dog out there. Thanks, Jose, for making that video at kind of last minute too. So good job. But we actually pushed up the launch of Flux so that we could launch it here at VapiCon. So thanks to the Deepgram team for doing that. Yeah. So Flux solves what I would call the big challenge with voice agents right now is that interruption sort of latency trade-off. And there's it's kind of the big thing that's in the way right now for many use cases. I wanted to talk about what the numbers look like. And then also, by the way, you're going to have a chance to try Flux at our booth that's right outside the door. You'll be able to experience it in real time. And actually, the quotes from folks who have been using it are like, it's insane. Like the latency is super low for the tokens to come in. The update is way faster than Nova 3 if you've used Nova 3. But then this end of turn detection is kind of a game changer. But I want to give credit to the folks who have worked in the last year on getting end of turn right. Everybody's had to kind of build and figure this out. And we were kind of sitting on our hands while we built this model and just kind of oh, the model's not ready yet, and then now it's ready to release. But this is what the world looked like before Flux. And higher is better. I'll just give you some guidance here. The higher is better. You want your end of turn accuracy to be high, okay? But one of the trade-offs here is latency. So you want the confidence to be extremely high, but you want it to be extremely high really quickly as well, so that you can get back quickly. And so if the farther left you go and the farther up you go, the better it is. And so this is the performance of Flux. It's a drastic pushing of the frontier. And I know a plot doesn't really quite give the feel, so go try it out. Which is that it's a little hard to understand how much does something like Flux or other models affect the voice agent quality. So we built a voice agent quality index, which essentially looks at latency, interruption rate, response coverage, et cetera, and just folds it all down into one number. We call this VAQI, and Koval, I don't know if Brooke's here, but hey, how's it going? Great QA company for voice agents. If you don't know them, Koval, work with them. But we got some great feedback on this as well from a benchmark perspective. And And so if you use Flux in a voice agent versus other systems that are out there, it scores really high. I mean, so again, you kind of have to take our, you don't have to take our word for it on the VAQI. You can look at how it's calculated. There's a blog post, et cetera. But it weighs all of those options. And so when you build a voice agent with Flux, it really helps out. Yeah, and we have a lot of great launch partners for this. So today you can use Flux on Jambones, LiveKit, Vapi, Pipecat, Cloudflare. You can do your testing with Koval, and then we have some early customers that tried it out and gave us a lot of product feedback. So I listed them as well. So yeah, go sign up. Go. Go hit those services, go talk to the founders that are here and the people that are working there, because you'll be able to use Flux in it today. You'll be able to select it from a drop-down or, that type of thing. Yeah, and here are some of the quotes. So, Jordan has some good things to say about it, that, solves one of the hardest challenges. Dane from Cloudflare is a great partner, represents a great next evolution. I like this phrasing, that's a next evolution, because there's still more to go, and we'll talk about that in just 1 minute. But yeah, thanks everybody for testing this out and giving feedback on the model. So the final thing to talk about with Flux is that we're going to offer it for free for all of October. So yeah. So it's a new, it's a new type of model that I know it takes a little bit of thinking about how you're going to utilize it. Am I going to keep my VAD still? Am I going to keep my other end of turn detection? I want to make it easier for you to try it. So who cares? Just use it for free, up to 50 concurrent connections, which is a lot. And if you need over 50 concurrent connections, just talk to our team and add it to your contract or whatever it is, because it's production ready. It's ready to be used at scale. And also, you'll be able to do that with support through any of the orchestration platforms, like those that are listed. So you can just use it through there as well. All with that same free situation. But are we done yet? No. Have we reached the summit? Have we gotten to that audio Turing test? Not yet. We're closer. We're walking up the mountain. And what's happening here? What's standing in the way? Basically, I would say one of the next big hurdles is context. You could also think about what Jordan said, memory. They're all part of this context, basically. And what I would say is, if you look at the words on the screen, hello does not equal hello, and it's kind of a stupid statement. But in text land, those do equal each other. But in voice land, they don't. There's tons of different voices say things different ways, and it's just an easy example.
Hello.
Hello?
Hello.
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 Hello. Hello.
So just that simple word, the way it's said tells you a lot about what is going on. The acoustic environment that they're in tells you a lot about what's going on. And so I think the next big frontier is figuring out context. So cool, the voice quality, latency, interruptions, et cetera. They're getting really well handled, right? Well, there's more to go. You've got to get context right. And so this is why we built Neuroplex at Deepgram. So I'm not launching this as a product today, but I'm just telling you this is a way to think about how to solve that context problem that works for B2B, that works for scale, that is controllable, that is inspectable, that is debuggable, et cetera. And we've written a white paper about it. You can go check it out. We have an open source model in there for the text to text LLM portion. It'll be a model that Deepgram develops that goes in there for bidirectional streaming. But I think it's really helpful to think about what's happening in Neuroplex when you think about the cascaded systems that are built now for most voice agents, where you have speech to text, it casts everything down into text, right? And then you have a text to text, like an LLM, it's everything comes out as text, And then for text to speech, well, text goes in, and then it finally expands it back into audio, and all this richness is gone. And so when you're thinking about it that way, you're on the left here, where every word is just a point in parameter space. But actually with Neuroplex, every word, there is no just single word, but every word occupies a part of the embedding space and parameter space. So, young, old, excited, not, et cetera, all of that information is still contained in there. And the reason to bring it up now is that Flux is the first part of that. So Flux, you can inject context into it. It outputs more context, like end of turn and that type of thing. But this architecture is going to be expanded, and we'll be expanding our text to speech as well. So forthcoming announcement there around text to speech. And then we'll also fill in the whole system with Neuroplex, and we'll work with all of our partners to support that in the orchestration layers as well. So yeah, with context, actually now we could, it's my prediction that we'll be able to pass the audio Turing test, at least in a B2B use case in the next year, in an arbitrary use cases like in the next 2 years. But are we done yet? No. This still needs to scale because like a science experiment is cool and everything, but it needs to be shipped to 1 billion interactions that happen every day, like the products that all of you are building, et cetera. And the way I think about going up this mountain is, you're the heroes, you're the ones that are building all of it and going there and doing that. And Deepgram and other companies here are playing their part as like Sherpas that are helping everybody get up the mountain. And how we think about that is just our Deepgram, the Deepgram Enterprise runtime, just this runtime where it's not just models. Okay, so I'm releasing a Flux model today, but actually that runs in a runtime that is extremely scalable. It's distributed across the world with our partners, et cetera. It gives you super low latency, gives you super low reliability. If you need a hybrid system where you run it in your VPC or whatever, you can totally do that. That's all part of the Deepgram runtime, and you can use that with all the partners here. So I look forward to partnering with everybody on that. And if you want to follow what we're doing, you can check us out on X. You can message me if you want. Connect with me on LinkedIn. We've got a great Discord server where you can check us out. We'd love to do co-marketing with our partners. You can see we talked about a bunch of them today in this talk. But let's do billboards together. Let's do events together. We have let's do it. So thanks everybody. I appreciate it, and we'll end it there.